So we're speaking about search techniques, and what we want to do is understand how you use randomization in search techniques, and better understand how the rate of changes of the target function, rate of change of the slope, if you like, is impacting the random choices that you may take in order to improve your search techniques. And we're going to go through a very simple example of random choice, and we'll see how uniform random choice translates into non-uniform random choice as a result of the change in the slope of the curve. Okay? So have a look here. I have this simple function, x squared, okay? And I'm choosing a point uniformly in this interval. A squared plus delta, a squared minus delta. I'm choosing a point uniform. And I want to understand how the slope impacts the distribution of the square root of p, of the point I've chosen. Okay? So let's calculate. So I want to understand what's the probability of getting a point here between a and a plus epsilon, or getting a point here between a minus epsilon and a. Okay? So what is this probability? It's simply, for this segment, just take a squared and a plus epsilon squared, and this is the segment that if the point falls here, the square root of, if the point P will fall here, the square root of P will fall here. Okay? So basically that's the segment that I'm interested in. Okay? And the probability of getting that is this length divided by the length of this segment, which is 2 delta. Okay? Now if you follow the algebra, this is a epsilon 2a plus epsilon. Why? Just simply, open this. Okay, you see that? Okay. So this is the probability of getting here. This is A. Now, I'm interested in the probability of getting here. Okay? So same type of calculation. I want to understand what's the probability of the square root of P getting to here. Okay? Now again, this will be a minus epsilon squared. So that's the segment we are interested in. The probability of getting here is a minus epsilon, right? So it will be a squared minus a minus epsilon squared. And that's this, okay? Over the same length of the segment. So these are the probabilities, because we're talking about uniform probabilities. So this is the probability of getting to B. Now if you divide A and B, you see it's not the same, right? The curvature influences the probability. So the curvature of x squared influences the probability of A and B. Although I'm doing a uniform choice here it's not uniform. That's my point. Okay? And also, so here this part A is bigger, and B is smaller. Okay, if you divide the two, you get this ratio, because epsilon cancels and 2 delta cancels. Okay? So if you look at this, just take A equals 1. Just as an example, an epsilon equal a half. and you divide the two. So insert A and epsilon here. You'll get, when you divide, you get 5/3. Okay? So basically, this is the factor, this is how much bigger A will be compared to B. So the end result of this is that you're choosing uniformly here, getting a non-uniform choice here, so you'll be preferring to go in this direction if this is a search problem. Okay, now you want to say something?
Yes. Can you deduce the distribution of A? You have the...
Yeah, you can.
B is uniform.
Yes.
But what type of distribution is A?
So that's an excellent exercise. All you have to do, instead of doing this, try to calculate the following probability in any point. Okay? And now you'll feel comfortable doing it because you already know how to do it. Because this is it's similar. And then you'll see what the probability is exactly, what the distribution is exactly. Now, because of that, this is the same technique. This is the same mindset that will bring you to techniques of simulating any distribution when using a uniform distribution. So as an exercise, you can think about the exponential distribution. Okay, and try to see how you simulate it using a uniform distribution, using the same ideas. Okay, that's it.